Okay, this is just a quick replacement video because the audio wasn't working yesterday, and it won't hurt you guys to get a little bit of review of what I told you yesterday. So, it was about day 3 of identities, and this one I hope by now should be easy for you. This kind where you just see something and I'm looking at my sheet going, okay, there's all these identities. One of them must be the same as that, and you guys know what it is? What is it? Cosine squared. So I can put in cosine squared down there, and that will make it easy because then it's cosine over cosine squared. I can do one more step and cancel off some cosines, and I'll have 1 over cosine, and that'll be secant. That kind's supposed to be easy by now. So I was focusing on the new kind, which involved this, which was the theme for the day was basically using what's called, you remember what they're called? Conjugates. Very good. The conjugate. And so in this problem, for instance, the conjugate of cosecant plus 1 is cosecant minus 1. Notice I have to do it to the top and to the bottom because to keep a fraction the same, that's what you'd have to do. Then I do the same thing on the other side because it had cosecant minus 1, so we use cosecant plus 1 and cosecant plus 1. One on the top, one on the bottom. When it simplifies down, we end up with the beauty of a conjugate is that when you multiply it all out, you FOIL it out, you get a perfect square. Cosecant squared minus 1, and that's on the sheet. You guys remember that one from the one with the coat is cozy? Okay? And so then cozy minus 1 must be the cotangent. All right, that's one of the ones you can get on the sheet. So that part there turns into cotangent and cotangent. And then the tops can be added, and that became 2 cosecant. And the minus 1 and the plus 1 just cancel each other out. So I got 2 cosecant over cotangent squared. And then I suggested what I would have done, a little different than this teacher did, is I would have said 2 cosecant and then cotangent, cotangent's on the bottom. So I would multiply instead of dividing by 1 over tangent. I would multiply by tangent, so this will be a tangent squared on top. Tangent theta, tangent theta. That's the way I would have done it because I would have taken cotangent and made it into 1 over tangent. And by dividing by 1 over tangent, I'm multiplying by tangent over 1. And I split my tangent squared into tangent, tangent. Then the last step is I got my 2 from of my final answer. I was supposed to have a 2 here, right? I got my tangent. How do I get a secant? This times this equals secant. Why? Why does cosecant tangent equal secant? It's like a little mini proof. Cosecant times tangent needs to equal secant because then I'll be done. I already have my 2. I already have my tangent. I just need a secant. Who can tell me why this becomes secant? Yes. Change it all into sine and cosines. And that was the other theme for yesterday. And again, this is just a replacement video for yesterday. Is if you're stuck, try changing everything into sines and cosines. And it sometimes just all works out. Let me show you why. Cosecant is, in terms of sines and cosines, cosecant is 1 over sine. And in terms of sines and cosines, what's tangent? Sine over cosine. And look at that. Once you actually write them down in sines and cosines, a lot of times things cancel. Cancel, cancel. And then you have 1 over cosine. And what is 1 over cosine? Secant. That's what I needed, was that secant. And now I have all the pieces. Now I'll reveal the actual final proof steps here, but I just wanted to kind of talk you through how I would have done it. But let's pull this off completely. There we go. And this teacher did it a little bit of a different way. At the end, they end up with this. If you want to look through it more slowly, you can slowly parse through what the teacher did step by step. All right, so then I'm going to go over to this other side. And I was telling you, change everything into sines and cosines is a valid option. I know a lot of you might have tried to do this with conjugates. Unfortunately, I don't think it works well with conjugates. So you end up having to change everything into sines and cosines. When we do that, this tangent is sine over cosine. This cosine. or sorry, that cotangent is cosine over sine. Then we have to make it, the 1 turn into cosine over cosine. This other 1 turns into sine over sine. That gives us common denominators. And I want to point out one important little sneaky step in here that I want to focus on for today's new lesson. As you're going through this, did anybody get to a point where they had cosine minus sine here and sine minus cosine there, like opposites? You got stuck there, right? A lot. Oh, maybe you didn't. Cool. Some of you figured out what to do. Do you get that cosine minus sine is different than sine minus cosine? Those are not the same. So how do you make them have a common denominator? Well, the teacher has these little neato arrows that are like switching things around, but I want to take a second to talk about this because for today's new stuff, it's really important to get. If I have x minus y, do you know what the opposite of that is? The opposite of it. No. Negative y plus x is the same as it is. Do you get what I'm saying? That's equal to it. What's the opposite of it? Y minus x. Again, I know some of you said negative x plus y. Good, because that's the opposite of this and the opposite of that. See? The opposite of the positive x is the negative x. The opposite of the negative y is the positive y. But it's simpler than that. You just switch them around. If I had sine minus 1, and I want it to be the opposite of that, I can multiply it by negative 1, and I will get, what? 1 minus sine. Again, I didn't say they were equals. I said they were opposites of each other. Let me show you the simplest of them all. 5 minus 2. What is that, by the way? It's 3. What if I want the opposite of that? 2 minus 5. 5 minus 2 gives you 3. 2 minus 5 gives you negative 3. All right, so it's important to understand opposites are something that's like multiplied by negative 1. So in the middle of that proof, the teacher needed to be able to get sine minus cosine and cosine minus sine to end up being the same as each other for common denominator's sake. So how do I get one of these to switch so it's like the other? I multiply it by negative 1. Can you do that? Yeah, if you multiply by negative 1 on the bottom and on the top, do you get how that's legal? You're just multiplying by negative 1 over negative 1. And what does the bottom turn into? Say it. Sine minus cosine. So now it's negative 1 on top over sine minus cosine. And now I've got a common denominator. And now I could keep going. All right, so the two themes for the day for yesterday were conjugates, where again, if I have 1 plus sign, you can multiply by 1 minus sign. And the other theme was turn everything into sines and cosines, which is what this is an example of, and then common denominators. And then this is where they did the little dance. That was backwards from this. So they multiplied by negative 1, and here's their negative that allows them to do that. And then they changed it so they have the same denominator. And then once you get cosine squared minus sine squared, you had to factor it. I taught you briefly about that yesterday, so that's the last thing I'll remind you. This is, again, that replacement video for the sound that didn't work. If I have sine squared theta plus cosine squared theta, that's equal to 1, right? What if I wanted the opposite of that? Because I could multiply by negative 1, and it will be the opposite of that. All right. So do you get then I could replace this with 1? But what if I had the opposite of it? What if I had negative sine squared theta and negative cosine squared theta? Do you get I could replace that then with what? Negative 1. This I could replace with positive 1. If this is the opposite of that, I can replace it with the opposite of 1. I can replace it with negative 1. All right, so that's important to understand the concepts of opposites. All right, so we'll talk more about that in today's new lesson, but that's a replacement for yesterday's. Basically, the strategies of turning everything into sines and cosines and the strategy of conjugates. I know that's a super quick replacement that is not meant to be a full lesson, but it should be enough to substitute for now.